Good evening and welcome everyone for today's webinar, The Continuous Delivery of Data with Dave Farley. Before we proceed ahead, a little detail about us. Pingala Software. Pingala Software is a startup building product using cutting-edge technologies such as blockchain, IoT, etc. We provide built-in quality development solutions in the field of automation, IoT, blockchain, etc., in collaboration with the customer. Our endeavor is to bridge the gap between technology and society through our product, services, and apart from that, we help organizations in their DevOps and agile transformation journey. We also provide limited and specialized technical consulting and training pan-India along with the product development. Today we have Dave Farley with us. Thank you for sharing your valuable time with us, Dave.
It's a pleasure.
Dave
Thank
Farley
you.
Dave Farley is a pioneer of continuous delivery, thought leader and expert practitioner in CD, DevOps, TDD, and software development in general. Dave is passionate about helping development teams around the world improve the design, quality, and reliability of their software by sharing his expertise through his consultancy, YouTube channel, and training courses. Without taking any more time, I hand over now to Dave.
Thank you very much, and thank you for inviting me to talk today. So my talk today is about the continuous delivery of data, and I talk about continuous delivery a lot. I am one of the authors of the book Continuous Delivery that popularized some of the ideas around working so that our software is always in a releasable state. And so I do get involved in talking about that a lot. One of the questions that I often get asked is, okay, so all that sounds good, working so your software is always releasable, but you can't do that for data. And I think if you're not doing it for data, then there's a problem. And so this is really what my talk is about. So how do we include data in our ability to work in ways that keep our software in a releasable state? So let's start out by thinking about what continuous delivery really is, and maybe not quite what you think. So we're trying to go from idea to valuable software in the hands of our users and customers as quickly and as efficiently as we can. And we want to gather feedback from that so we can learn and adapt our products and ideas to better meet the needs of our customers. These days, I increasingly think of continuous delivery as a genuine first-class engineering discipline, by which what I mean a couple of things. So one is that it's the application of kind of scientific style philosophy and principles to solving problems in software. And the other is that it's a practice that amplifies our ability to do the job better. If you think about engineering in other disciplines, engineering is, in essence, the stuff that works. It's the way in which we build things with the most efficiency and the most quality. And so we should be striving to find those sorts of tools, behaviors, processes of our own. And I think these ideas on the screen are important if we want to be able to do that. We need to control the variables. We need to be able to try out ideas, and we need to understand the messages that we're getting back from those ideas. We will not want to try and get to the point where our software is more deterministic, so that we can make a change and we understand the impact of that change. We want our processes and our approaches to be repeatable and reliable, so that if we do something and we get one result and we do the same thing again, we're going to get the same result. We want to work more experimentally so that we can learn better how our ideas land with our users, how good the quality of our software is, and so on. And for that, we also need some form of measurement where we can kind of gather information to make stronger, more evidence-based decisions. I tend to use this diagram to represent the ideas of continuous delivery. We're trying to establish this pipeline of evaluation. And this is the deployment pipeline that is at the heart of the continuous delivery book. And the deployment pipeline is often misunderstood. It's not just a workflow. So if you have a build pipeline and a test pipeline and a release pipeline, you don't have a deployment pipeline. A deployment pipeline is about going from commit to a releasable outcome. So we're trying to create this repeatable, reliable process for releasing software. In order to be able to do that, we've got to automate everything and keep everything under version control, do things more quickly so that we can learn more quickly. Treat quality as a first-class citizen and don't cut corners on quality, and so on, so that we get real feedback. But there's another take on this. Continuous delivery is the ability to get changes of all types, including new features, configuration changes, bug fixes, experiments, into production and into the hands of users safely and quickly in a sustainable way. This doesn't say anything at all about code. It doesn't mention only code. So this is about the whole system, the stuff that's going to be useful for people. So the fundamentals of if we want to establish a repeatable, reliable approach to be able to do this is that we're going to need to version control everything, really. If we want to be repeatable, reliable, control the variables, and carry out experiments, we want to make change in small steps so that we can understand the impact of that change and that change alone as far as possible. We want to test everything, really. And we want to design to allow ourselves the freedom to do this, which means in terms of data, we must design to assume that we're going to be coping with data migration. So what do we need to version control? The code that we create, certainly, and everything else. Data needs versioning too. It's not really continuous delivery if we can't release because we've made a change to our schema. Our aim is to work in a way so our software is always in a releasable state. That means that if we want to make a change to our schema, we've got to do that and maintain our ability to release that change into production. So what do we mean by data? Well, you know, it's all data really, but in the context that we're discussing today, we're going to differentiate between the data that is deployed at release time and that's generated at runtime. And so the deployment time is kind of straightforward. We put that into version control repositories. It's easy to understand what's going on. But for the stuff that's deployed at release time, that's generated at runtime, it's a little bit more tricky. And that's really the focus of my talk today. There are some gray areas that around the edges of this. What about reference data? What about runtime configuration? But primarily the focus of my talk is the data that is generated by our systems at runtime during the operation of those systems. So there are different contexts that matter in terms of that kind of data. So there's the data that is in production, which is the real stuff that we want to protect. But there's also data that supports automated testing, that supports manual testing, performance testing, migration testing, and so on, that we might think about. There are two facets that are relevant, whatever the nature of the data that you collect. There's the records, the actual elements of data itself, and the structure that we use to interpret those records. So records and structure are the two sides of the coin that we need to be thinking about when we're considering data in production. So we want to work in a way that allows our structure to evolve. Continuous delivery is a kind of second generation agile approach to software development, and agile is all about kind of keeping our ability to make a mistake. So we want the freedom to be able to not perfectly predict all of the ways in which our data must be used in future. We want the freedom to be able to learn, to realize that something has changed in our requirements, and therefore the structure that we want to store and deal with must change too. So we need our structure to be allowed to evolve. There's a quote from Fred Brooks, the author of The Mythical Man Month. As soon as one freezes a design, it becomes obsolete. So we don't want our designs to become obsolete. Therefore, we want to retain our ability to change things. If structure can evolve, we must migrate data. We must cope with the case of being able to move data from version 1 of a structure to version 2 of a structure, or version 17 to version 18, whatever it might be. For structure to evolve, the best way to do this is to make all changes additive changes. Deleting things, updating things is a more complicated kind of change. So it's easiest if we always add things. Think about, in most cases, I am not only talking about SQL databases throughout this presentation, but it's an easy way to understand what I'm talking about. So I will tend to use the language of SQL when I'm describing things, but try and map that to any other store of data. It's just as true of NoSQL databases, or even informal data stores, in your own models. In terms of what we're talking about. So think records and structures, but I'll tend to use the terminology of SQL. So if we want to make additive changes, think about having a table. It's much easier. We can have a table and just add a column at very little impact on the software that's reading the tables or writing to the tables. So that's a freedom by making additive changes that we can gain. We want to version control the setup of our data, the structure itself, the schema, and so version controlling things like DDL and migration scripts and delta scripts, everything. There should be no manual intervention. We're trying to eliminate people going in and changing anything in a production system through admin consoles or manual scripts. We want to automate this stuff and version control this stuff. We're going to create automated tests to validate changes with respect to data migration and use database refactoring techniques to help us. So let's start thinking about that in a bit more detail. Let's think about versioning schema changes. So schema version is best based on a monotonically increasing sequence number. Each delta change to our schema ticks the sequence. That way we can understand the order in which we should carry out migrations, that we can understand, we can build these things as additive changes bit by bit that allows us to apply them incrementally. So we're going to store the desired schema version with an application. The application is always going to be working at some particular version or narrow range of versions with respect to schema. And we're going to store the version of the schema along with the data. So now we can imagine at the point at which we deploy an application, the application says, I need schema version, I don't know, 73, and the schema is at version 72. Therefore, I've got to apply changes to migrate it from 72 to 73. And that kind of move. So we're going to keep these, we're going to version these things and keep track of them. So let's imagine that. Here's a little model. The balls represent our application. The tables represent our data store, and we need to understand which version of the application works with which version of the data store. We need to capture that relationship somewhere. Our application is going to be at some version, our schema is going to be at another, and we need to know whether these are going to be successful in working together. So somewhere we need a, let me just move this out of the way. I'm not quite sure whether this is in the way of the picture. I'm going to move that to a different screen. There you go. So somewhere we're going to need to keep a map that says that version I of the application works with version N of the schema, and then as we make changes, version I of the application works with version n+1 of the schema, and so on. We're going to need to record that in some way if we want to automate all of this and version control all of this stuff. So that relationship needs to be encoded. So the easiest way to do that, to maintain that relationship, is to keep them both in the same version control system. Bung them in the same repository, and then they can't be out of step. If every time you need to change the schema, you do it in the same version control system as the application, you are guaranteed that they are in step with one another. So that's a nice, easy model to do things with. Then we can have a whole series of versions of the application, and with them the associated schemas that they work with, and it's clear that that's all going to work out. So this isn't just about schema versioning. This is also about data versioning. In addition to that, there's a different kind of stuff. There's not, as we said before, there's not just the structure, there's also the records, and that's a different kind of problem, because we don't have access to the records, because the records are generated at runtime by our clients. Therefore, we've got to start thinking about the migration of the data. So if we move from schema version 3 to schema version 4, that's going to impose the need for us to migrate any data that was at version 3 into a version 4 of the data set, the records themselves. So we need to start thinking about those migrations too. So let's extend our model a little bit. So here we've got some users that are working on changes to the application or changes to the schema. Remember, they're in the same version control system. So they're going to keep changing those things, and each time they change the schema, they're going to write a little Delta script, a script that says, this is how you migrate records that were in version 75, in this case, to version 76. And we're going to put all of that, the Delta scripts, in the same version control system, along with the application and the schema definition. So now we know that what changes work. If we make a change to the Delta script, if we make a change to the data, we increment, add a new Delta script to do the migration. And every time we make a small change to the structure, we update our migrations to cope with that change in the wild. Each of these scripts is only moving one step at a time. So the script Delta 1 goes from version 76 to 77, the script Delta 2 goes from version 77 to 78, and so on. Again, we keep all of these in the same version control system. So what do these Delta scripts look like? So we're going to have something that scripts the schema change itself. We're going to have the migration, how we move from the previous version to the current version, how we move records. And then if we're sensible, we're also going to have some tests of those migrations to check that the stuff, that the move that we're making with our data is working in the way that we expect. So every single time that we want to make any change to our data store, we're going to write all three of these things. We're going to write the thing that makes the change itself. We're going to write the migration script that moves records, that translates records from the previous version to this new version. And we're going to write some tests that just validate that those migrations do what we think that they do. And as ever, we keep all of these things together in the same version control system so that they have a one-to-one relationship with the application. So now we can imagine deploying our system. Here's our version control system with all of our Delta scripts. Here's a test environment, and this test environment, remember what I said at the outset, is that we're going to keep the version that the application needs with the application. We're going to keep the version that the schema is at along with the data. So in our test environment, in this example, this test environment is at version 79. So the latest version of our application requires sequence number 80. So at deployment time, our deployment tools can notice the difference between the two, pick Delta script 4, which is going to move us from 79 to 80, apply it to the database in the test environment, and now the test environment is at version 80. Similarly, in production, whatever the range in production, we're probably not deploying to production quite as frequently as we are to a test environment. So we come to deploy here. This is at version 76. So now our version 80 of our system requires us to do a more migration. So we can look at the gap between where the data is at in production, 76 in this case, and where we want it to be, 80 in this case, and then play all of the Delta scripts in order to make the migration. Now, bit by bit, the production date steps towards the version that we want it to be. It's now at version 80, and now the application can use it. This is quite flexible, but there's one further step. If we wanted to be able to undo our changes, we could decide to keep a script, a Delta script, that did the step back. As well as being able to step data forwards, we could also write a script that stepped us back one position. Now we can migrate any version of the application, of the data store, to any version of the application. We can move forwards or backwards in time. Now, there are some catches to this, some things to be wary of, specifically around losing information. If some of your migration scripts lose information in their process, it might not be possible to migrate back, which is another one of the reasons why it's always good, if you can, to take an additive approach to changes. But this is a quite flexible way of doing things. Now, if we want to move to 81, we can kind of play 80. We can undo 81 and step back to version 80 if that's the version that our application needs. What I've described so far is what I would call a deployment time migration pattern. So you would run this kind of process as part of your development process, and by default, at the point at which you deploy your software, you run all of the migrations that I've just described. This is a good way of doing things, but it's not always enough. So there are some other migration patterns that are worth thinking about. So this is what I've just shown you is a deployment time migrator. On deployment, the system migrates all old records to whatever version it needs them to be. The advantage of this approach is that it's easy to understand. We can think about this, and it's a reasonable amount of work to manage these Delta scripts, but it's a much more repeatable, reliable approach to making changes than kind of storing them up and then worrying how do you get from a version years old to the current version. This small incremental change is the best way of breaking this problem up. It can be implemented as startup behavior of the system or deployment time behavior of the deployment tool. So the system could apply these migrations itself, or we could separate it out and run it as part of our deployment strategy. The downside of this is it's rather difficult to test. It's also difficult if the migrations take a long time. It can be slow, and it tends to require the app to be down while the migration takes place. And so speed is important. And so those two problems are kind of in tension a little bit. This is not ideal for frequent continuous delivery style deployments. So let's look at some other strategies that are probably better placed for keeping the system live while you are doing these sorts of migrations. So the first one is a pattern that I call Lazyreader. So in this pattern, the system can always read old versions of the data. Each record is versioned. Each individual record of data is versioned in this case, not just the schema. When a record is accessed, a suitable reader is selected from a pool of readers that the system maintains and translates the old version of the record into the new view of the record. And so the reader presents a consistent, up-to-date interface to the system, whatever the internal data structure that's hidden behind those readers. This is nicely implemented using strategy patterns. You have a consistent interface to your readers. It presents always the newest view of the data that you're looking at, and you key those readers based on the schema version that you're interested in to select the appropriate reader as a translator. This is kind of runtime translation. This is as scalable as you're going to get, because it shares out the costs of translation to the costs of operation in the system. This can cope with very, very large data sets. It's good for hot deployment because the system's can always translate to the version that it needs. It's scalable. It can cope with vast amounts of data because the translation cost is, again, on every read, and so spread out over time. The downside is that you're adding a fair bit of runtime complexity. You've got a significant maintenance overhead in terms of keeping all of these readers that can do the translation all of the time, from every past version to the current. And it never achieves consistency in data. This is really good for those large data sets. So I once worked on a trading system where we were generating, we were processing more data than eBay on a daily basis. And we were generating kind of roughly a terabyte a week of data. There's no way that you can afford to go and rewrite that kind of scale of data. And so we just kind of maintained this data out as a stream. And when we read it, we used this Lazyreader strategy so that we could always translate even old versions of that stream into whatever the system needed at this point. The next of my patterns is Lazy Migrator. So now we're not just going to read the data, now we're going to translate it and write it back out. So the system can read old versions and write out new versions. As each record is versioned again, and when a record is accessed by the normal operation of the application, the application notices that it's an old version and selects a suitable migrator to translate the old version of the record into the new form and write it back out to the data store. Excuse me. Again, this is nicely implemented as a strategy pattern and using the schema version as a key to identify which migrator to use. The best use case for this is for hot deployments and large data sets. It's good for live deployment. It's extremely scalable. The translation cost, again, is shared out at read time of each individual record. Migrations can be chained together, and so it reduces the maintenance overhead. We can kind of imagine, reading a very old record and playing the migrations one at a time until it catches up to the latest version that we need. The system is eventually consistent with respect to data. Once every data has been accessed by the current version of the software, it will have been translated. The downside of this is, again, it adds quite a lot of runtime complexity, and there's no obvious signal that the migration is complete. It may be that you update the application before all of the translations it happens. That doesn't matter because of the chaining, but it's an overhead, if the data consistency as it's stored matters, then that's a problem. And the maintenance overhead is the maintenance of this large collection of this ever-growing collection of migrators. Next in my list is the Downtime Migrator. So here the system can read old versions and write new, same as before. In this strategy, each record is versioned once again. Old records are scavenged. They're kind of found by the system when the system's not doing anything else. So in downtime, when it's not really busy, it just goes looking for work. It goes scouting around, looking for old records and migrates them when it's not busy doing other things. This is, again, good for hot deployments and medium to large-ish data sets. It's not great for vast data sets, because there's going to be, you know, a limit to how much downtime you have. It's going to be finite. And so the amount of time that you can spend migrating data is finite. And if your data set gets too big, that might overtake the window that you've got to do the work in. This is good for hot deployment. It's scalable. The translation cost is when the system's not doing anything else. So that's nice. It's doing useful work when it's not busy doing other things. You can discard old translators. Once all records of a particular version have been migrated, you can dump the translators, which means that you keep the maintenance overhead down and keep the ever-growing complexity of your migration under control. The system is eventually consistent with respect to data, as long as you've got enough downtime to do the translation work. And again, you can chain the migrations. You can look for old versions of the records and translate to the next version, and then keep doing that until it's up to date. The downside is, once again, adds runtime complexity. It may be inappropriate for vast data sets because of the reasons I've described. Migrations on top of migrations start to make us a little bit nervous in terms of the complexity. And again, it's a maintenance overhead maintaining this collection of translators, but a little bit better than some of the others because you can dump the ones that have completed their jobs. Those are the patterns that I've used in real systems and seen work. There are probably some more patterns, but those are the ones that tend to spring to my mind when I'm thinking about keeping data live. Let's think a little bit about testing these migrations. I think that one of the commonest mistakes that people make is that they test the end state of a database, that it ends up in a particular state. Instead, I think treat the testing of migrations more like unit testing, sort of test-driven development style approach to testing your migrations. What you're really trying to evaluate is, does the migrator work in the way that you think the migrator works? And so that kind of testing is best done with fake data and fake examples, so you can run these migration tests quickly and efficiently and get good feedback on those. There are a few tools that help you, primarily with the more static approaches, the more deployment time migration approaches that I talked about at the start. FlyWayDB will manage your deployment scripts for you. Redgate and DB Maestro will both do similar things, but they'll also do some other things in terms of being able to move relational databases from one state to another. And so that those might be worth a little bit of exploration if you're interested in this. And that's the conclusion of my talk. I'm more than happy to take questions about any of this stuff to explore in more detail. One thing, before I unshare my screen, just point you to the links. I've got a blog site. You can catch me on Twitter, and I've got a YouTube channel that's growing in subscribers and views quite quickly at the moment. That covers quite a lot of detail of my take on software engineering in general, but also some of the stuff that we've talked about here today. Right, let me just unshare my screen and we can get to answering some questions. Any questions?
So thanks, Dave. It was really a very knowledge-packed session. So guys, I mean, if you have any questions, either you can type in the chat box or you can ask directly from with Dave.
If you haven't got any questions on data migration, I'm happy to take questions on other stuff, but let's start with trying to talk about data migration first. There's some interesting stuff in terms of data as a problem and continuous delivery in the context of machine learning, which I didn't go into in this, but I think it's an interesting problem, and I think actually it might be closer to regular software development than we might think in terms of the answers to that problem. So if you want to ask any questions around that too, happy to talk about that too. So I'm going to be optimistic and take the fact that there aren't any questions to mean that my presentation was so good that it cleared up all of the answers that you might, all of the questions that you might possibly have. Unlikely as that may seem. So the migration strategies that I've described were, so one of the projects that I worked on was the creation of one of the world's highest performance financial exchanges. And I started working on that project while in the middle of writing the continuous delivery book. And so that was kind of an exercise in what you can do with continuous delivery as an approach if you've got a blank sheet of paper. And we applied at different parts of the system in different contexts. We applied, I think, all of these strategies in one form or another that I mentioned here today. The primary migration strategy was the first one that I talked about, the deployment time strategy that we did. And we did this for our entire enterprise system for this exchange and all of the software around it. We could make any change to our production system and evaluate that change to the point that we were ready to deploy it into production and get an answer back in 57 minutes, including evaluating all of the data migrations that we've just described. So this is quite a good way of working if you want to stay on top of changes and understand where you stand in the position of being able to make changes safely and reliably to your systems. Still no questions.
Anyone having any questions?
So let me I'm going to fill in. Go ahead.
Hey David, hi, this is Chaitanya. I just want to ask one question. You mentioned about a TDD kind of approach for data migration. Can you just elaborate more on that front?
Yeah. So the fine-grained behavior of TDD is really focused on giving you a verification that your code does what you think it does. There was some academic research and analysis of over 200 projects in production that analyzed production failures. There's kinds of errors, mistakes that you get in production. And what was found was that about 60% of defects in production are caused by the simple common kinds of mistakes that every programmer puts into code, whatever the language or technology that they're using. So, off by one errors, conditionals the wrong way around, scoping errors for variables, those kinds of mistakes that if you've done any programming, you kind of recognize because they're the kind of mistakes that we all make. So if you do basic test-driven development, you write the test first and you run it and you verify that the code does what you thought it did, you eliminate that 60% of production defects. For data migration, it's kind of a bit riskier than most kinds of changes, because what you're doing is that you're presumably your customers and your users have stored up valuable information in the data that have generated using your system, and they want to hold on to that information, whatever its nature, and you're about to go and change it. So you want to be pretty sure that you're going to be able to do that safely, and maybe unwind it if it goes wrong. But you want to be pretty sure that that's going to work, because if it doesn't, you're going to have destroyed something that your customers and your users value. So I think even more than most things, ensuring that your migration scripts do what you think they do is important. And the engineering discipline that gives you the strongest assurance of that I am aware of is test-driven development. So the way in which, when we did this for our exchange, the way that we set this up was that we built some tools to help us write these data migration scripts. So we did some stuff using XSLT that would allow us to create small data, sample data examples that we could use in our tests. Then our migration script our test would kind of deploy those to something that our migration scripts could work on, and we usually used an in-memory. If it was relational data, we usually use an in-memory database so that we could run these tests efficiently. And then our tools would allow us to script the data quickly and efficiently. They'd deploy the data to our in-memory database. We'd run our migration script against that, and then our tools would validate that the outcome was what we expected given that test data. And then we'd do a few different cases to kind of test different aspects of the migration script in the similar way that we would for test-driven development of a regular piece of code. That gave us a much stronger trust that our code was doing what we thought it did. We did something else in addition to that. So that still left us a little bit uneasy that we might make a mistake. So one of the other things that we did with our exchange was that we did we did migration on a sample of production data as well. So that was less precise, less accurate in its evaluation, but taught us some other things. So what we did was, the first strategy that I've just described, the kind of unit testing for data migration scripts, if you like, that was the primary tool that we used to build these little Delta scripts. Then, in addition to that, what we would do was that each day we would take a copy of a section of our production data, and on an automated basis, our scripts would anonymize that production data, because it was a finance system. We weren't allowed to have real production data in test environment. So it would anonymize the production data, bring it over to a test environment, and then every release candidate that went through our deployment pipeline that day would be deployed against that reasonably up-to-date version of the production data. And so each release candidate would run its deployment time migrations against that production data and migrate it to the version that the application needed. We'd then run a small set of kind of smoke tests to just sanity check that the system still looked as though it was in good shape and it was sane after the migration. But there's a limit to how far you can kind of take that sort of testing. So the primary lesson that we learned with that second stage of testing was, did it take too long? Did this data migration, when running at production scale, take too long for the downtime that we had available for our application? And then if it did, we'd say, oh, well, for this migration, maybe we need to move that into one of the other strategies that I talked about later in the presentation. So that kind of 2 level of testing gave us a lot of confidence that at the point at which we migrated the data, it was going to work, and it was going to work in a reasonable amount of time. Does that answer your question?
Sure. Sure, yeah. Thanks, David. It gives a different perspective, because we understand about test-driven development in many different contexts, but when you talk about data migration especially, exactly how do we actually use that approach to come up with this in this specific area is quite interesting. So yeah, thanks for that.
Yeah, it's a thing that I think it's an area where there aren't great tools, I think, and I think it's an interesting idea that there could be some better tools in that space to be able to help with those kinds of applications.
There's some disturbance here.
Please,
Also, you may
yeah, sorry for that.
yeah, thanks.
Any more questions?
Okay, one last question, David, because we're talking on a subject. Do you recommend any automated testing tool, especially when you're doing any kind of data testing with large volume? Say, for example, especially for the BI area, right? When we use ETL tools like Data Stage, Informatica, and load data from different sources, right? In that context, you want to really test a large volume of data. Is there any kind of tool which you recommend, especially in terms of the open source side?
No, I'm afraid I can't point you in the direction of any tools. Most of my experience of doing this kind of testing has been with kind of tools that we wrote ourselves to suit the problem that we had at hand. I'm not aware of any tools that make a significant difference in being able to do this. I think it's much more about kind of the patterns in the way which we approach our work. One of the things that I probably should have recommended that I didn't was that there's a good book on working with data in more agile ways called Refactoring for Databases, or is it Refactoring for Data? I can't find the book at the moment, but so it's an excellent book by Scott Ambler and Pramod Sadlaj, and it's been around for quite a while, but it goes into lots of different little refactoring patterns. So things like if you want to delete a column, what are the steps to take to delete a column in a database? That kind of thing. So it gives so that's one tool that you could use, is the book, the information in that book, in terms of strategies for managing data and data migrations. That's worth thinking about. But in terms of testing those things, I can't think of anything that I've come across that is particularly useful.
Sure. Thanks, David, for this. Yeah.
Pleasure.
Hi, David.
Hi.
Hi, I have one question regarding there is also a question around the tracking and involving the data scheme over time, and whether those changes are backward, forward, incompatibility, and data validation. If you take an example like
So I'm sorry. I'm sorry. I missed the end of your question.
If you are in a streaming world, okay, and then these, as for example, these aspects of data version become more complicated. Okay, right now there is a question around the tracking and involving the data schema over time, whether those changes are backward or forward in terms of compatibility, in terms of data validation, and in terms of security. Okay, as for example, if you are in the streaming world, right? So in this scenario, these aspects of the data version become more complicated. So what will be our approach regarding this?
So I don't think that's significantly different to the advice that I would give for any other form of code, really. I think that one of the key ideas in agile thinking is that we want to try and adopt ways of working that give us the freedom to make changes. And so
Okay.
whatever the nature of the change, we want to be able to do that. And part of the reason for that is so that we can keep changing things and allow our software to get better. I think that there's kind of a cultural assumption in software development that systems always get worse. And I don't think that's necessarily true. They get worse if you ignore them. Like Fred Brooks' quote, as soon as you freeze something, it's kind of dead. So the way to stop systems getting worse over time is by giving yourself the freedom and the permission to change them. So as you learn more, you modify them to better suit the circumstances that your system is in. So that might mean that your data structures and data stores become more complex, but it might mean that your data structures and stores become more targeted at what the new system does. The tools that I've talked about in terms of the migration strategies give us the opportunity to stay on top of that management in terms of structure and records, so that we can change them if we need to. And then if our system grows, if our system is very complex and grows in complexity, sorry, Roshan, could you mute your microphone?
Sorry, actually some.
Cool. If your system is very successful and you know grows in complexity, and that's just a function of your application, that's not a bad thing. It's just a function of your system over time.
Okay, thank you, David.
Pleasure. Any more questions?
Guys, do we have any more questions? Okay, so then, David, I guess we are good to wind up this session. Thank you so much. It was really an honor to have you, and it was really a great session. So with this note, I would like to close this session. So thanks, David. Thanks for your valuable time and your rich experience, what you have shared with us. And thanks everyone for joining this session.